The journey of the anchor cable begins not with the sea, but in a choking haze of dry vegetable matter inside the hemp house, where the air is so thick with particulate dust that sunlight struggles to pierce the gloom. Bales of raw hemp, likely imported from the frozen ports of Riga or St. Petersburg, arrive here stiff and compressed, smelling of earth and long storage. Before a single inch of yarn can be spun, this chaotic mass of fibers must be disciplined, a task that falls to the hatchelers. These men stand before heavy wooden benches, each mounted with a hatchel, a formidable board bristling with polished iron spikes capable of tearing bare flesh to ribbons. The work starts with breaking the bales, shaking out the rough bundles of plant stalks that have been retted and scutched, but remain tangled and coarse. The hatcheler grips a handful of raw hemp, known as a strike, and swings it rhythmically, lashing the fiber down onto the steel teeth of the coarse hatchel to comb out the debris. This is a process of violent separation, where the hatcheler pulls the bundle through the spikes with significant physical force to straighten the long fibers and strip away the short, tangled waste known as tow. The sound is a constant, rhythmic rasping, like heavy canvas tearing, repeated thousands of times a day. As the iron teeth catch the knots and straw, the air fills with a fine, golden dust that coats the worker's skin, eyebrows, and lungs, creating a work environment that is technically simple but physically punishing. A veteran hatcheler is judged by his ability to maximize the yield of long, clean fiber without breaking it, a subtle, tactile judgment made with every pull. He switches from the coarse hatchel to a finer set of spikes, refining the texture until the rough plant matter resembles soft, silky hair, aligning the fibers perfectly parallel to one another. The distinction between the high-quality hemp and the waste tow is the first critical quality control measure in a chain that leads to the safety of a 1,000-ton ship. The waste is cast aside for lesser purposes, like oakum or rough twine, while the long, combed fibers are carefully gathered. The hatchelers work in a kind of grim silence, not out of unfriendliness, but because breathing is a calculated effort in the dust-laden air. They tie the combed hemp into measured bundles, usually weighing a few pounds each, creating a standard unit that ensures consistency further down the line. By the time the sun sets, the floor is buried in debris, and the men cough up the day's labor, their chests tight from the hemp plague, having transformed a chaotic agricultural crop into the disciplined raw material required for the spinning grounds. Emerging from the dusty confinement of the hemp house, the material moves to the rope walk proper, a structure that defies architectural norms by stretching for nearly a quarter of a mile in length. It is a long, low, narrow shed, often lit only by open slats along the sides, designed to accommodate the sheer linear requirement of spinning uninterrupted yarn. Here, the spinner prepares for his day by wrapping a substantial quantity of the combed hemp around his waist, creating a distinct apron of fiber that looks like an oversized belt. He attaches a few fibers from this bundle to a hook on a spinning wheel, which is a large, wooden apparatus situated at the top end of the walk, turned tirelessly by a wheelboy or a laborer. The creation of the yarn is an act of walking away from the source of power, a backward march that the spinner will repeat until he has covered miles of ground without ever leaving the building. As the great wheel turns, transmitting rotation to the small whirls where the fibers are hooked, the spinner begins his retreat down the long, dark alley of the walk. He walks backward, feeding fiber from the bundle at his waist into the twisting yarn with his hands, a process that requires a deeply ingrained finger feel. He is the sole regulator of the yarn's thickness. If he feeds too much hemp, the yarn becomes lumpy and weak. If he feeds too little, it becomes thin and brittle. His hands must sense the tension and the twist smoothing the fibers as they spiral together, all while walking at a consistent pace that matches the speed of the wheel far down the track. It is a mesmerizing dance of coordination, where the twist travels from the hook down the length of the forming yarn, locking the fibers together through friction and torsion. The physical demands of this stage are deceptive, for while it lacks the violent exertion of the hatchel, it requires an endurance that borders on the ascetic. A spinner might walk over 20 miles in a single day, all while moving backward, his eyes fixed on the yarn forming in his hands, completely blind to the path behind him. Along the length of the rope walk, rails or posts with pegs are positioned to support the sagging yarn as it grows longer, preventing it from dragging in the dirt. When the spinner reaches the end of the walk, perhaps 1,000 feet away, the finished yarn is wound onto a reel, and he must walk all the way back to the wheel to start again. This relentless pacing creates the fundamental unit of the cable, producing thousands of fathoms of yarn that must be uniform in diameter and strength. For any irregularity here will be buried deep inside the final cable, a hidden flaw waiting for a storm to reveal it. Before the white spun yarns can be trusted to endure the corrosive salt of the ocean, they must undergo a radical chemical transformation in the black house. White rope, while strong, acts like a sponge, absorbing water and rotting from the inside out within months of exposure to the sea. The solution is Stockholm tar, a thick, dark, pungent substance distilled from pine roots, which arrives in barrels and is heated in massive copper kettles set into brick furnaces. The environment here is a stark contrast to the dry dust of the hatcheling room or the cool draft of the rope walk. The black house is a realm of suffocating heat and acrid resinous fumes that cling to hair and clothing for weeks. The tar must be brought to a specific temperature, hot enough to become fluid and penetrate the fibers, but not so hot that it scorches the hemp, which would render the rope brittle and useless. The yarns are wound off their storage reels and dragged slowly through the boiling tar bath, submerging them completely in the sticky black liquid. This is not a passive soaking. The yarns are pulled through by capstans or horsepower, moving at a steady rate to ensure even coating. As the sodden, dripping yarns emerge from the kettle, they pass immediately through a nipper or a constriction plate. This device squeezes the yarn with immense pressure, forcing the tar deep into the core of the fiber bundle while stripping away the excess surface liquid, which drains back into the kettle. This step is crucial for the weight of the final cable. Too much tar makes the rope heavy and stiff to handle in cold weather, while too little leaves it vulnerable to rot. The visual transformation is absolute, turning the golden white agricultural product into the iconic black cordage of the Navy. The men working the black house are stained permanently by their trade, handling the hot, sticky yarns with leathers and tools caked in layers of hardened resin. Once tarred, the yarns are hauled out to a drying area, often coiled on capstans or laid out on racks, where they steam in the cool air, the volatile compounds evaporating to leave behind a flexible, waterproof glaze. This process adds roughly 25% to the weight of the hemp, a significant increase that must be accounted for in the logistics of the shipyard. The yarn is now cured, preserved, and ready for the mechanical violence of the twisting process, having survived its baptism of fire to become a material capable of defying the elements. The creation of a massive cable is not merely a matter of brute force. It is a feat of engineering that begins with the precise geometry of the register plate. Standing at the head of the rope walk, this heavy iron disc is perforated with concentric circles of holes, looking somewhat like a giant colander. The master rope maker must thread hundreds of the black tarred yarns through these specific apertures, a task that requires patience and mathematical foresight. The arrangement is never random. The number of yarns is calculated based on the desired circumference of the final cable, and they must be distributed evenly to ensure the rope remains perfectly round under tension. A mistake here, a crossed yarn or a miscount, would create an internal weakness that could cause the entire cable to deform or burst when straining against a storm anchor. The workers move with deliberate care, pulling the sticky ends of the yarn through the iron holes, grouping them into bundles that will eventually form the strands. Once threaded, the process of warping begins, which is the critical equalization of tension across the entire bundle. The yarns are stretched out along the full length of the walk, sometimes spanning over 1,000 feet, and attached to the hooks of the heavy laying machinery at the far end. The challenge lies in the fact that no two yarns are spun to the exact same length or elasticity. If one yarn is tighter than its neighbors, it will bear the entire load when the cable is stressed, snapping instantly. If it is too loose, it will crinkle inside the rope and contribute nothing to the cable's strength. To solve this, the men must patrol the length of the stretched yarns, shaking and adjusting them, ensuring that every single thread hangs with the exact same degree of catenary curve. It is a tedious, visual game of leveling, where the collective strength of the cable relies entirely on the uniformity of its thousands of individual parts. This stage represents the transition from individual craft to collective structure. The yarns, now arranged and tensioned, form a dark river of hemp floating waist-high down the center of the building. The air smells strongly of the fresh tar as the fibers settle into their alignment. The master rope maker inspects the register plate one last time, checking the concentric rings of yarn for symmetry. This static moment of perfect alignment is the calm before the storm, a fleeting instance where the arithmetic of the design is visible before it is twisted and locked away forever inside the spiral of the rope. The intellectual labor of the design is finished. The physical violence of the twisting is about to begin. The signal is given to the men at the winches, and the immense machinery begins to turn, initiating the foreturn that will transform the parallel yarns into a solid strand. This is no longer work for a simple spinning wheel. It requires heavy, geared capstans or cranks, often turned by horses or teams of sweating men, to generate the massive torque needed to twist a bundle of hundreds of yarns. As the hooks rotate, the yarns begin to spiral around one another, and the sound in the rope walk shifts from the quiet shuffle of feet to a low, growing groan. This is the sound of friction and compression, often described as the screaming of the fibers, as the yarns are forced together with such intensity that they become hard as wood. The diameter of the bundle shrinks rapidly as the twist eats up the length, pulling the machinery down the tracks on its sled. The physics at play here involves the storage of potential energy on a lethal scale. The yarns want to untwist, fighting against the force being applied, and the tension on the equipment becomes terrifying. The men operating the winches must maintain a steady, unyielding rhythm, or any slip or sudden release could cause the cranks to spin backward with bone-breaking speed. Heat is generated within the core of the strand due to the internal friction of the tarred fibers rubbing against each other, sometimes becoming hot to the touch. The rope makers must monitor the angle of the twist constantly. If they twist too hard, the fibers will shear. If too soft, the strand will be flabby and weak. It is a balancing act performed with tons of pressure, turning the loose collection of yarns into a single, cohesive cylinder that rings like a metal bar when struck. The result of this violent compression is the strand, the secondary unit of the cable. A typical anchor cable might require 3 of these massive strands, each one as thick as a man's arm. Once the strands are formed and hardened by the twist, they are kept under tension, vibrating with the stored energy of the rotation. The atmosphere in the rope walk is charged with danger. A snapped strand at this stage would lash out like a bullwhip, capable of cutting a man in half. The workers move with a wary respect for the material, knowing that they have trapped a tremendous physical force inside the hemp. A force that gives the rope its spring and elasticity, but also makes it a coiled snake waiting to strike if mishandled. With the strands formed, the final and most dramatic stage of laying the rope begins, presided over by the most skilled and daring worker on the floor, the top man. He rides or walks behind a device called the top, a solid, conical block of hardwood with 3 deep grooves cut into its sides to guide the strands. The top is inserted between the 3 strands at the closing end, acting as a wedge to keep them apart, until the exact moment they are allowed to twist together. As the machinery at both ends of the walk turns in opposite directions, adding twist to the rope while removing twist from the strands to maintain balance, the top is squeezed forward by the closing rope behind it. The top man's job is to regulate the speed of this travel, sitting on a heavy sled or sledge attached to the top, using his own weight and drag to control the angle of the lay. This is a position of high visibility and high risk. The top man is literally riding the point of convergence, where 3 massive rotating snakes merge into one. He must judge the lay by eye, ensuring the spiral is tight and uniform. If the top moves too fast, the rope will be loose and long-jawed, prone to kinking. If he holds it back too much, the rope will be too hard and short, losing its breaking strength. He signals the winch teams with hand gestures or shouts, orchestrating the speed of the twist while sitting inches away from the crushing point. The friction on the wooden top is so intense that it smokes, and the top man often has to apply tallow or grease to the grooves to prevent the wood from charring or the strands from burning. The sled moves slowly down the length of the walk, leaving behind it the finished rope, a perfect spiral of 3 strands. The top man is the conductor of this industrial symphony, feeling the vibration of the manufacture through the seat of his pants. He watches for cockles or kinks, instantly halting the work if a strand tries to loop over itself. His expertise determines the mechanical efficiency of the cable. A well-laid rope shares the load equally among all its fibers, while a poor one destroys itself. When the sled finally reaches the end of the walk, the top man steps off, his legs vibrating from the tension, leaving behind a continuous solid cable that looks as if it were machine-made, yet owes every inch of its uniformity to his daring ride on the sled. The production reaches its zenith with the creation of the cable-laid rope, a monster of engineering that is effectively a rope made of other ropes. While a standard hawser consists of 3 strands twisted together, the great anchor cable for a first-rate ship of the line is formed by twisting 3 of these massive hawsers into a single, colossal unit. This fractal structure, twisting twists upon twists, is necessary to provide the elasticity required to dampen the shock of a ship surging against its anchor in a gale. The setup for this operation is a logistical spectacle. The 3 constituent ropes, each already as thick as a man's leg, are stretched out and attached to the heaviest winches the rope walk possesses. The sheer stiffness of the material means that standard cranks are useless. This operation requires the brute force of up to 80 men, laboring in coordinated gangs, heaving against long winch bars to force the thick ropes to spiral around one another. The resistance offered by the material at this scale is immense, as the cable fights every inch of the rotation with the stored energy of thousands of individual yarns. The closing of the cable is a slow, grinding battle where the friction between the 3 hawsers generates significant heat, sometimes enough to soften the tar to a liquid state again. The master rope maker must carefully manage the forehard, the extra twist put into the individual hawsers before they are combined. to ensure they don't untwist during the laying process. The sound of the cable closing is a deep, rhythmic thumping, like a heartbeat, as the massive lobes of the rope settle into their final configuration. It is a dangerous time. If a winch gear were to slip, the recoil could shatter legs and ribs like matchsticks, unleashing the tension of a drawn bow on an industrial scale. Visually, the result is awe-inspiring. A solid cylinder of hemp and tar, often exceeding 20 inches in circumference, possessing the rigidity of a tree trunk rather than the flexibility of a string. The surface is hard and slick, the individual strands locked so tightly together that water cannot penetrate to the core. This is the cable, a capitalized distinction in the naval world, representing the ultimate tether between the floating world of the ship and the solid ground of the seabed. It is no longer just fibers. It has become a composite structural beam, engineered to withstand shock loads of over 100 tons. As the final fathoms are laid, the men are dripping with sweat, their muscles burning from the sustained effort of conquering the stiffness of the hemp, birthing a serpent that will lie in the dark of the cable tier until the moment of greatest peril arises. The final act of the manufacturing drama is the wrestling of the finished giant into a transportable form, a task that rivals the spinning in physical difficulty. A fresh, hot cable is incredibly stiff and unruly, possessing a memory of its straight alignment that it fights to maintain. It does not want to be coiled. A large crew of men must grapple with the object, often using levers and pry bars to force it into a large, flat spiral, shouting in rhythm to coordinate their shoves. This is the sleeping serpent, a moniker earned by the cable's tendency to spring open violently if not properly secured. The men work with a wary exhaustion, knowing that the cable is still alive with residual torque, settling into its permanent shape only as it cools and the tar hardens the bonds between the fibers. Once coiled, the sheer mass of the object presents a new logistical nightmare. A single anchor cable can weigh several tons, a dead weight that must be moved without the aid of modern cranes. It is rolled onto heavy sledges or rollers, a black monolith of labor moving slowly toward the dockside. The transfer to the ship or a lighter barge is a delicate operation, often requiring capstans and block-and-tackle rigs to hoist the coil from the wharf. The workers who guide it know that they are handling the most expensive single consumable item on a ship, a product that represents months of agricultural labor, weeks of processing, and days of specialized craft. Every inch of the cable has passed through human hands multiple times, from the hatcheler's bloody fingers to the top man's scorched palms. As the cable disappears into the dark, damp hold of the ship, coiled down into the cable tier, it marks the end of the industrial process and the beginning of its maritime life. It lies there, smelling of pine forests and sweat, a dormant muscle waiting to be flexed. The infinite knot is finally tied. Not a literal knot, but the continuous, unbroken chain of friction and twist that binds the Baltic fields to the Atlantic storms. When the hurricane blows and the sails are furled, the safety of 700 souls will hang entirely on the integrity of the work done in the dusty, noisy gloom of the rope walk, trusting their lives to the friction between millions of individual fibers that refuse to break. The men of the rope walk walked backward into the dark so that civilization could sail forward into the new world. We are dedicated to retracing their steps, ensuring that the dignity of their craft is never lost to the dust of time. Help us hold fast against the current of forgetfulness. Subscribe to join our crew and pass this story on to someone who values the weight of history. Down below, tell us, what other lost trade should we unravel next?